Hi friends, now we will start discussion on the second part of the module, cultivation of algal biomass and treatment of wastewater. In the first part of this module, we have discussed on different types of algal species that can be used for the oil production and how the lipid content can be increased, etc. Now, in this module, we will concentrate on how to grow the microalgal biomass, then what will be the reactor systems for cultivation and growing of the microalgae, and what will be the harvesting process, how can we harvest the separate the algal biomass from the media, and then treatment of wastewater using microalgae. So, at first we will see the different reactor systems which can be used for the production and the growth of microalgal biomass. So, the most conventional one is the open pond. We can use some microalgal seeds and microalgae in open pond, and those will be growing, and then we can collect it as shown here. So, here this is a very open pond systems, that is open just like a pond, and that is microalgae is grown here, and another is that is closed photobioreactor, closed systems. So, this is called photobioreactor, open pond, opened and closed systems. Photo, sunlight is required, biological, that is microalgae is required for the conversion of carbohydrates in these reactors and lipids, proteins, etc. in the algae. So, there are two open system and closed system photobioreactor. This is one example is open system. Here the feed gets entry, this is open to atmosphere, open system means open to atmosphere. So, feed is getting entry, the water, wastewater is coming here. So, this is a pond, and in this pond it is microalgae is growing. So, after a certain time we are getting out the microalgae. So, we are separating the biomass and then it is recycled again, this will go to this and will be coming with the feed. So, this is the flow sheet for the open system photobioreactor, but closed system photobioreactor, this will be closed, and the vessel we can use different vessels, so tubes maybe or columns maybe or flat plate maybe. So, plate, horizontal tube, vertical tubular. So, all those types of photobioreactors have been used under closed category, closed system category. The plastic bags have also been used in some cases. We will see here the closed system photobioreactor, that is horizontal tubes. So, this is our media, we are taking in case of wastewater, say this is our wastewater, and we had some growth nutrients for the microalgae, and this media is pumped through these tubes. So, these are our photobioreactors. So, these are closed and there is no direct connection with the environment, sunlight is falling on these, and the sunlight will raise the temperature of these tubes as well as the inside water or the media which is passing through it. After that, when it will be coming out from this system, after certain time and sufficient growth when we will get, then some part of this biomass will be separated from the water stream, and that is called harvesting. So, harvesting will take place and the rest water some part with microalgae will be recycled to this your media. But what is happening in this case, when we are using sunlight, there are some photosynthesis reactions. So, oxygen will be produced. So, once oxygen will be produced, so that oxygen has to be removed, that is why degassing is needed here. In case of closed system, degassing is required. So, air is sent and exhaust it is going out, oxygen is going out. Oxygen is not desirable because photosynthesis requires CO2. So, and cooling and heating can also be required depending upon the atmospheric condition, because during say summer season, so temperature is around say 40-45 degree centigrade. So, here the water will also be around that 40 degree centigrade, that has to be the temperature has to be reduced. But if it is a cold country or very cold situation, So, at that time heating may also be required. So, this is the flow sheet or the concept of the horizontal tubular photobioreactor, and here we get solar ray on horizontal photobioreactors. You see here these are the tubes, this can have some spiral shapes also, and the column photobioreactor, this is one vertical column photobioreactor, these are number of columns. So, from one side the feed is getting entry, it is going out from the first column at the top, again it is getting into the bottom and from the top. So, that way it is going through one after another column. So, it is getting sufficient time for the growth of the microalgal mass, and after certain times we will collect from one end of this and we will separate the microalgal biomass from it and we will recycle the water. So, this is the operation of the closed photobioreactors. Here the closed photobioreactors may be of helical types also, the spiral types also, this type of systems are also available. So, in this in out, so in your spiral, but it is in vertical position. So, that way also some arrangements have been tested, the people have tested on this. So, two types of, one is a vertical column and vertical spiral vertical column photobioreactor, and flat panel photobioreactor is also another example people have tried with this. This is a flat panels when the media is kept and algae is grown, after a certain time is separated and harvesting takes place. Now, if we compare the open and closed system photobioreactors, then we will see they are very different in nature. So, if we fix some parameters, say important parameters for comparison are say required space requirement, that is very important, whether water loss, carbon dioxide loss, oxygen concentration, and then temperature, whether there is any shear, so shear, and then cleaning, and then contamination risk, whether any risk of contamination, biomass quality and biomass concentration, and then we will see production flexibility, process control and reproducibility. So, if we think about these parameters, then we can get some clear distinction between these two types. All these types have some advantage and disadvantage, and those will be discussed now. So, obviously the space requirement is very high for open ponds, but for this photobioreactor, continuous photobioreactors or closed photobioreactors, this is low. Then water loss also is very high in case of open pond, during rainy seasons it will be vaporized. So, water loss will be, carbon dioxide loss will also be high in case of open pond. Oxygen concentration, so oxygen concentration in case of closed photobioreactor we need to degas it, but here we do not need to degas for oxygen separation. And then temperature is highly variable, some control possible by pond depth, that but temperature control is not very easily attained here, but here cooling often required, we need to cool and we can maintain the temperature. And the shear, and then we are coming to cleaning. Cleaning requirement is also higher in case of closed photobioreactor, because open pond we do not need to clean the system, but closed systems requires cleaning, and contamination risk is also low in case of closed photobioreactor, which is high in case of open photobioreactors. Biomass quality, obviously you will be getting high quality biomass in case of closed photobioreactor with more control parameter, but here open ponds we will not be having that much of quality, and most important that may not be repeatable also. One time we may get certain biomass, the same conditions we may put or try to put, and we may not get the same amount of biomass. And biomass concentration, obviously the open ponds will be having less, that is 0.1 to 0.5 gram per liter, but if it is a closed system then we can get say 2 to 8 gram per liter. So, these are the difference between the open ponds and closed pond systems, and both the systems are having some difficulty, when people are investigating further to improve the performance of these processes. Now, we will compare different types of closed system photobioreactor, that is tubular, column and flat panel. So, these three types if we compare, and basically the biomass yield, if we exposed surface area for light illumination, that is very important, because that will be directly related with the cost of the process, and so cost, manufacturing cost, and then we are getting problem due to O2 and CO2 accumulation, then scale up possibility and maintenance cost. So, these are the different parameters or characteristics if we consider, then we see the tubular is maximum biomass yield, maximum exposed area for sunlight illumination, manufacturing cost is low, and problem due to O2 and CO2 accumulation is also very high, because it is tubular, it is closed, and in this case it is having the maximum the O2 and CO2 accumulation, and scale up possibility is also high in this case tubular one, and maintenance cost is also medium, but it is more than other column and flat panel. So, all those three types has their own characteristics and all are tested, but which one is the best one so far, it is not yet understood. More investigations are going on this. Now, this slide gives us some dimensions for research scale investigations for open pond, horizontal tubular photobioreactor, vertical column photobioreactor and flat panel photobioreactor. So, these are the typical dimensions which the people have considered. So, that is depth 1 to 15 centimeter for open pond, for horizontal tubular photobioreactor around 2.5 centimeter diameter, and this vertical column photobioreactor 2.6 centimeter, and flat panel that is 3.2 centimeter. Now, we are coming to harvesting part. The photobioreactors will help to produce the algal biomass, and then harvesting is coming and important for the separation of the algal biomass from the media. So, here there are two steps. The first step, in the first step, that is called bulk harvesting. Our target is to get more biomass along with water. So, here 2 to 7% dry weight we are getting. Once we are getting that 2 to 7% dry weight biomass, further we will go for filtration. So, we will remove all the water present in it, and this will be water will goes off and we will get dry biomass actually. So, this is the flow sheet for the harvesting, and the two step methods this is, and first is bulk harvesting and then followed by thickening. And this bulk harvesting, there are different techniques the people have tested, that is sedimentation, flocculations and flotation, and for thickening centrifugations, ultrasonic agitations and filtrations. So, these are the different techniques have been reported in literature for the harvesting of algal biomass, but still we will see now that all the processes having their own limitations and advantage and some characteristics, and requires further investigation and improvement. Now, we will see what is flocculation and how it works. The flocculation is used to aggregate microalgal cells which are dispersed in the media, and then this flocculation helps to increase the effective particle size. However, the difficulty is that for increasing effective particle size we need some flocculants, and these flocculants alters the nature of the cell walls. So, that is the main drawback of this process, okay, and the wall is affected by conditions of the cell at the time of harvesting. Then normally alum and ferric chloride are added as the flocculants, and this method is open to expensive also. Apart from these two, auto flocculation is also possible, particularly when metals are present and we are disrupting carbon dioxide supply, then the pH of the media changes and the metals are positively charged, and they capture the negatively charged algal biomass. So, that is called autoflocculation. Now, we will see some mechanistic path of the flocculation. So, flocculation is the process, as I have discussed, that helps to bridge the colloidal particles. The particles come closer and makes floc or flake, and then either spontaneously or due to addition of clarifying agent. So, we may add some clarifying agent or we may need not to add some clarifying agents. So, there are two types of flocculation, that is, one is perikinetic, another is orthokinetic. So, perikinetic flocculations refers to the flocculation due to Brownian motions of the colloidal particles. So, colloidal particles will be moving and will be colliding each other, and they will be aggregation will take place, and orthokinetic means some slight agitation is required. So, apart from this we need to add some chemicals in some cases, those are called flocculations. So, this is practically used for the separation of the algal biomass. And what happens, alum, iron or calcium or magnesium salt if we use, depending upon the pH, these salts forms hydroxides. So, aluminum hydroxide AlOH whole 3 whole 3, it may be AlOHN, number of and gigantic molecules is formed. So, bigger agglomeration is formed here of this aluminum salt, means hydroxides. So, these aluminum hydroxides captures, if there are small particles here, so though captures it. So, this is the mechanism of the flocculation. So, apart from this, some organic molecules are also added, and those organic molecules like say modified polyacrylamides, they are also having a bigger size and they also captures the small particles and separates it. So, this is the mechanism for the separations of the flocculation. Now, flotations and sedimentation, these are two also important process for the harvesting of algal biomass. So, what will be happening when we will add some flocculants, then small algal cells will be coming together very close and will create agglomeration and bigger size particles. Now, if we pass some air in the media, then these particles may be in floating form and this will be coming at the top of the media and that can be separated. So, that is called flotation, and sometimes if the size of the particles after agglomerations is bigger, so those can be settled also. So, in that case we will get the sedimentation. So, sedimentations enhances the efficiency of the process, but this through this gravity sedimentation we can get 1 to 5% of the solids in the settled part of the settled biomass, and the sedimentation rate depends upon the size of the particles which are generated after the agglomeration. Now, we will see the centrifugation and ultrasonic agitation. As I have just discussed that sedimentation rate depends upon the size of the microalgal agglomeration. Now, if the microalgae cells are very small, the agglomerated particle size is not very big, the sedimentation is not able to settle it, at that time centrifuge will work, because in centrifuge the acceleration which is generated, that is more than 1000 times than the g values or the gravitational acceleration. So, that is why smaller particles can also be separated using centrifuge, but this method is very effective, the efficiency is high, but it has some disadvantage, it requires higher energy, as well as when the microalgae is separated, if high RPM is used, then those microalgal cells may be damaged. So, these are the disadvantages of these centrifugations. And ultrasonic agitations, nowadays some researchers have reported that ultrasonic field, if we apply in the growing media, then microalgae will be agglomerated, it will be under the acoustic forces, and this technique, when the particles are agglomerated and they will be separated through gravity sedimentation. So, this is the mechanism through the ultrasonic agitations the microalgal cells can be separated from the media. Next is filtration. Another method which is used for the separation is filtrations. These methods uses some membranes of modified cellulose, and the advantage of this process is this method it is able to collect microalgal cells with very low density. But what is the disadvantage? These membranes can be clogged, and for a longer time this may not be able to operate. So, the limitation is that the small volumes of the media they can handle, and the filtrations is best suited for large microalgae normally greater than 70 micrometer, or the smaller microalgae may be passing through the pores or of the membrane. Now, we will see some techniques the people have used for the harvesting of microalgae. So, here vacuum filtration, tangential flow filtrations, centrifugations and centrifugations have been reported, and where we see the vacuum filtrations and tangential flow filtrations, the membrane pore size was used at 0.45 micrometer, and 70 to 89% recovery of the biomass was possible, and by this process centrifugations around 90% to 95% recovery was possible. Here dispersed flotation, flocculation followed by sedimentation and micro flotations, the informations are provided. Here which is 93.6% in case of dispersed flotations, and micro bubbles it is 99.2% biomass recovery, and flocculations it is only giving us 60% recovery, and the flocculants added here is aluminum sulphate and zinc chloride, and in these micro flotations the pH was maintained 5, and ferric chloride coagulant was added also in this case. So, now other some examples, gravity sedimentations and flocculations. Gravity sedimentations was used, that was able to 60% biomass recovery, and flocculations 85 to 90% biomass recovery. Then here 25 millimole per liter aluminum sulphate was used, and for this another flocculant was also used, that is sodium hydroxide at the pH of 11 to 12. So, these are some comparison and some informations on some processes for the harvesting of algal biomass from the media. Now, we will compare the different methods. So, gravity sedimentations, inorganic chemical flocculations and polynucleotic flocculations, and centrifuge, filtrations, natural and pressurized, and then flotations, auto flocculation. So, these are different methods we can use for the harvesting purpose, and the relative cost are different. The very high cost is with centrifugation, and very high TSS yield is with inorganic chemical flocculation, but this method has some difficulty that we are talking that the cell wall will be changed, and that may create difficulty for oil extractions in later stage, and the deficiency of the method is affected by the media pH. Then gravity sedimentations is not very efficient for rapid biomass recovery from high rate algal ponds, and centrifugation we have already discussed the high cost, and filtrations and flotations also depends upon hydrodynamics of the systems, concentrations and properties of microalgae, and no information is available on this cost, yield and energy usage on autoflocculation. So, from this table it seems that all the methods are having some limitations. So, more investigations are going on to develop some new methods with less limitations and more economic feasibility. This is the major part which contributes for the cost to the whole process. Now, at last we will see some example of wastewater treatment using algae. So, algae how to grow we have discussed, how to harvest we have also discussed. Now, we will see some example through which the wastewater treatment has also been achieved. So, both In this slide we will see that municipal wastewater both autoclaved and raw form has been used and reported by Lee et al 2011, and they have considered three, that is nitrogen, phosphorus and COD present in the wastewater, that were 132.3, 215 and 2390 mg per liter respectively. So, they have performed the experiments in batch reactor for 14 days and 50 micromole per meter square second light density was used at 25 plus minus 2 degree centigrade temperature, and they have got say nitrogen removal of around say 90%, phosphorus is around say 81% and COD is around 90%. So, the same removal was also achieved with raw wastewater. So, not only municipal wastewater, industrial wastewater have also been tested by some researchers as reported Su et al 2011 and Chu et al 2013. So, here soybean processing wastewater and here they have used piggery wastewater. So, Chlorella pyronerosa was the first case, and in this case Chlorella Geopingenesis was used, and say initial nitrogen, phosphorus and COD concentration was 190, 46 and 8087 milligram per liter respectively, where the nitrogen, phosphorus and COD removals were 90%, 75% round and 84%. So, similarly the information for this are also given here. So, from these slides it seems that the microalgae are also able to remove nitrogen, phosphorus and COD from the wastewater. So, up to this in this module, thank you very much for your patience.